has lab of the future in it. And I'll lead with an opinion rather than a question. I find that the future is today, right? I keep hearing about lab of the future. I keep hearing about all these sessions, lab of the future. And many of them, many of the initiatives I find in organizations that are labeled lab of the future, they're really, investigations or research or prototyping or playing around, right? And my opinion is that we really need to roll our sleeves up and actually solve problems. And now we have the technologies, now we have the infrastructures, now we have the people that have the knowledge to do it. So I really encourage your initiatives in Lab of the Future to take a much more pragmatic approach and really begin doing things and finding the challenges, finding the difficulties, finding the problems to solve and beginning to solve them. So let's begin with asking the panelists going around about the challenges that you see in the current approaches to lab integration. We'll start from that end.
So, hello everyone. So I foresee the major challenges in the lab is the integration of the silos. So now we have basically technology available where we can marry the multiple silos. One is that the scientist which does the experiment into the lab, where the data is residing into, multiple pockets. The challenge is that how to extract those data and taking up into a unified platform and then generating a huge database and using that huge database and putting into the engine of AI and ML and then inferring something meaningful for the organization. So the one biggest challenge is the marrying the different silos, and second is the data security. So as currently all the labs are into the pipeline of integrating their instrument and creating the database. Once the database become a huge volume of the database, then the next challenge is that how do you secure your scientific data? Because now the attackers are, earlier they were attacking to the IT assets. Now they have started attacking to your OT assets. Now I think the third wave will come, they will be trying to attack your lab assets. So if you're doing something experiment and it is fully connected, and maybe some hacker may try to enter into your lab network and try to change something which you are trying to do. So that I foresee the major challenges.
Hi, thanks for this opportunity to share my view here. We had done implementation of ELN in 2004, so it's 20 years from now. And that time I was thinking that in next 2 to 3 years, every organization, small or medium, everybody will be using electronic lab notebook. But it's 20 years now and we are still talking about the importance of ELN. But I have not changed my mind. I'm still thinking that next 2 3 years, I think everybody will be using ELN. So integration is not a challenge. I mean, we always talk about integration with legacy system. Legacy data are important, not the legacy system. The problem is that we try to integrate current system, whatever we are using, and we try to fit that in the new system. So in doing that, we always end up in compromising some of the features of the system. And other problem that I have seen, that in implementation, there are two major problems. One is budget, of course. The second is the mindset. Mindset is the major problem. We have the mindset of the file and folder mindset. We like to organize our data, everything into files and folders. That creates problems. I have implemented a system in 3 different organizations. So even after implementation, people try to export data into Excel from the database and keep their Excel files separate. So they end up in generating so many files. So we started all this because we wanted to avoid those small isolated files, and at the end, we always end up in exporting file and creating more files. So that export features has to be minimized. That is actually not good. It is required, of course, when you are interacting with third party, if they don't have access to your system, then we need to share data. But this has to be kept only when required. that export business is really not good. I have seen people are exporting Excel file from Spotfire and then keeping them in the separate folder project-wise. So that doesn't serve the purpose. The whole purpose is gone for the database. Another problem is data, whoever is generated, the fields, the data has to remain with that person. And the sharing of data with email, so everybody has the same file. So that also creates a problem. So that has to be minimized. If you want a successful implementation, export has to be avoided. Sharing of data through email should not be encouraged. So that will really help in generating a database system that maximum functions and the features can be utilized.
I absolutely agree. I think that files are something from the 1990s. It was the best way to communicate. You could put it on a floppy disk and hand it to your colleague, or put it in an envelope and mail it to your colleagues. And we haven't really moved beyond that mindset, right? And it's one of the things we talk about with Signals ChemDraw. It's like, stop sending each other ChemDraw documents. Share them directly in the screen, together working, ideating, communicating immediately, right? And that mindset is missing. And as we begin to, as an industry, use tools to integrate, let's not just move files around and share files, right? I think that's a really key observation. It's about how do you enrich the data and place it in front of the user in the way that gets the most value, right? And the file is not needed anymore. In most scenarios, it's an artifact. And if it's needed, it's because it's an artifact of the history, and we should be hiding it as much as we can from the users. I 100% agree. That's one of the key challenges, hiding the files away. Thank you.
I think my rest of my other panelists has already spoken about the majority of key challenges. When you talk about floppy disks, it reminds to me, we always blame the technology that technology is not adequate. How many of you remember in 1969 when Apollo 11 had sent a man to moon, there was a computer which was being used. Do you remember what was the RAM size of that PC which was being used? Just to let you know, it was using 2.5 kilobytes of the RAM. And 2.5 kilobytes of the RAM was sufficient enough to make a man land on the moon. Now we are carrying more than 32 GBs in gigabytes of the RAM. From the various aspects, whether you call it integration, parsings, or different file formats, I think technology is available. William Gibson says that future is not there, future is already there. It needs to be evenly distributed. So I see there are companies, there are organizations which are doing excellent job with a complete orchestration of digital ecosystems. I think our adoption is not with the same pace. Coming back to the lab, since Ajit has very well explained about the integration in the lab, you have 4 types of file format, right? There are already database-based systems, there are file-based systems, there are RS-232 systems, and there are streaming systems, right? Now, sometimes we take problem as a over-exaggeration, right? If you have got 1 or 2 instruments which does not give you RS-232, just see in the back end amount of integration or exercise, how much that cost you, whether the replacing of that instrument would be cheaper. We need to take those decisions, because just to accommodate that 1 or 2 instruments which have been bought 2 decades before, the cost is X, but to make the data, bring it inside, the cost is much more. And then there are technology, I think Dr. Tanu sir has talking about, you have hand text recognition tools, you have automated text recognition tool, OCR is there, web scraping is there. So technology is not inadequate. It is the ability, strategy is something, ability to take decision the way we wanted to go ahead. So I would like to just say that.
Yeah, no, I agree 100%, especially your sentiment about, sometimes it's better to replace the instrument than to build around it. But it's not even that, because we live in a world where we're not really doing this well at all. Don't focus on the hardest problem first. right? And maybe you can replace, I mean, I understand that, resources are limited and you cannot replace every, dumb device in the lab first, well, but pick the ones that are already a little bit smart and that are not integrated and that are going to add value, right? And don't go all the way to the hardest problem to begin with.
Yeah, as I listen to everybody talking, I'm chuckling a little bit because we are intimately involved with a lot of the Lab of the Future initiatives many customers have. Some also call them Lab Without Borders. So you'll hear all kinds of initiatives. The thing that we have learned the most, which is a successful Lab of the Future initiative, is one that has well-defined business goals, as where the problems are well-defined and the goals are well-defined. The means to then solve those problems or to achieve those goals, like David said, exists already. Technology exists already. As you think through your digital transformation programs, you have to think about what are you doing it for? Is it compliance driven? Is it collaboration driven? We heard a lot about that. Is it driven so that you can leverage data, you can leverage AI to make certain decisions? Is it driven for cost reasons? So there are multiple reasons why you are deploying this program, and those reasons have to be well understood. So in response to that, one of the things we have done over the past many months is when we start working with customers, we first build out a value proposition. And we have something called as a value discovery book. So as you deploy our systems, we capture the value that you are getting as you are piloting our products or as you are deploying our products. That's what I'm.
So let's move away from we began with the challenges of connecting things, right? And which things to connect and how to get pragmatic about connecting them. And that's certainly sort of the initial problem. But in my experience, a bigger problem has to do with how do you maintain what you build, right? I mean, I've helped customers build very complex integrations, point-to-point integrations for 20 years, and they work. They connect anything to anything. There's more or less effort, more or less cost, typically more cost than less, but they always fail the same way. They fail to work consistently, reliably over time. So I'd like to get the opinions on the panel of sort of what can we do, what are we doing, what approaches are there to ensure that what's being built today doesn't suffer that particular challenge of maintainability.
Yeah, so part of and what David said is absolutely right. When you do point-to-point connectivity, step one may be the easy step, but steps 2 through N, where you are actually maintaining it each time the vendor changes something, each time technology changes, who's going to do all that maintenance, right? That becomes a huge issue for integrating these systems. We've taken those problems out of your hands, right? This is our business. The reason we work with the entire ecosystem is so that we provide you the latest and greatest connectivity that is out there. We also put our money where our mouth is. We say we don't charge for building connectors. We only charge for connections. The reason we don't charge for building connectors is because that's our business. So we don't charge for building, we don't charge for maintaining connectors. But it's a huge issue. It costs a lot of money to maintain these systems. Plus, it slows you down. Very often, I've had customers say, we want to deploy new technologies, we want to bring in new instrumentation, but we are afraid to do that because these new technologies and new integration will break our existing ecosystem. And that's not a good place to be in this rapidly changing technology world.
Anybody else want to comment on maintainability?
So So regarding maintainability, I think we have to learn from the plant system. So in the plant, we have a DCS system. So it is aggregating through a historian. So all the plants, those are operating with the standard OPC connector or a buses. So I think in the lab also there is a strong need of standardization. So where all the vendors actually agree to a standard way of data communication and a standard way of aggregating and repositing that data. And further, after that reposition of the data, it should be exposed to the various analytical tools. Like if I talk about the big analytical tools are Microsoft Power BI, Tableau, ClickSense, and others. So that you see the entire ecosystem can work if the vendor agrees on the standardization and they want to give away from the proprietaryship of the data. So if I am using something 5G network, right? So some companies say that I have a different technology, I will go with this technology, but that doesn't work for the entire ecosystem. If you say the electricity runs in India for some 50 megahertz or a particular kind of socket we are designing that this is a 15 ampere socket or 7 ampere socket. So there is a standardization available. So I think there is a lack of standardization into this domain. So there is an opportunity to basically replicate which is already standardized in some other domain and can be replicated here.
I guess I'll add a comment to the maintainability, and that's sort of, think about what is a competitive advantage to you, right? So is there an advantage in building something custom that connects your instruments and your systems? Do you get an advantage from it being your own special thing that you have to maintain forever and ever? Or is this a pre-competitive thing where, you know, it's better if the industry kind of has common standards, common approaches, common tools that we're all funding together, and then the advantage is that you get the actual data, right? That you get the scientists involved in the right way, that the data flows in the right way, and that's where your implementation of how you use the data, right? How do you analyze the data is your competitive advantage. And I see a lot of, you know, cycles wasted over the years in things that are really not helping you do better science, that are not getting you products to market faster, that in fact slowing you down because you're reinventing, you know, your own wheel multiple times. And so what I've seen in the maturity of the market now with centralized, cloud-based SaaS delivery mechanisms creates a great opportunity to say, look, this is not competitive. Let's just all kind of get behind it. Let's all, you know, Ajit said it, it's not just the customers, it's also the vendors, us and the instrument vendors and so forth. Let's just build an ecosystem so that the science can get done faster, right? That's my passion, and I really want to push the industry to really focus on that and not on the technical.
I can just talk a little, one comment on standardization, because we are in the middle of that as well. So we have implemented certain standards, right? You heard allotrope, ASM, you heard animal, all of that. Those standards get you to a certain point because they still provide you the common denominator, but they don't provide you all the data that you need to do your science. So every endpoint, every instrument company or informatics vendor will say, if we standardize, there's only a subset of our data that becomes available as part of that standard. Trying to get the instrument companies to standardize on one thing. I deal with instrument companies all the time. I've done that for 25 years. Many of them are now working with us because they look at us as a vendor neutral alternative, but they will rarely talk to each other, right? A customer may force to talk to them, but it's very reluctant. But this is the reality, and we call it instrument politics, but there is a lot of that in the industry.
Any other comments from anybody?
I think to that point, I fully agree with that, the birth and genesis of this database, community-based applications, whether you call it all the entire informatics suites, whether it's DMS, ELN, that was happen on a one track. And the development of this instrument fraternity, they have develop on another track, and they are actually lagging behind. They are not pairing. So I've seen that last decade before we started, bringing the PDF data, then in the your is right, getting the building the print drivers, doing markers, and getting the data extracted at the printing control, and then we started building text file, RS-232, bringing those files and all. Now, rather than waiting for this cycle to get matured, I think what is the standard format what is available, like you call it JSON, Python, right, coming from Java. That's more than enough to do and speak the same language in multiple platforms. Either you are using it is for data analytics, ML and AI stuff, are you doing for integration stuff? Let's say I'm taking a compound registration from Mosaic, making some those serial dilution inputs, sending to Biomac understanding it, sending it to TCAN do the SAPlet ready, and then it goes to LCMS, Waters or any other systems. They receive it, and once they get the data, I can actually arithmetically program them and create a report. In fact, in a couple of projects we are working on hands-free reporting. We don't want any scientist to spend time on writing a report. So I think they're difficult to get that instance where we have common platform for all data. Everybody, it cannot happen so soon. But by the time technology not it's not a barrier currently to that you cannot do that. If you give a very, I mean, sometimes I say, like success of Uber lies on the smartphone, right? In fact, if you go deeper, it was not a smartphone, it was actually GPS inside the smartphone. And if you say it was not even GPS, it was a satellite what you invented. And even if it is not satellite, was a rocket which was invented. And it was not rocket because you invented, how to do internal combustion. And finally you go further down, you will figure out, when we, explored the fire and when we started learning. So finally it comes to the human being. So in the core pivotal node, somebody was telling that whether the IT will do science or whether chemists will do something, right? So we need not be scared. So end of the day, if I formulate that way, digital transformation is something technology can give you an excellent prediction, but your precise judgment lies with you. And some of excellent prediction and precise judgment is not enough. You need to take precise, clear actions. That is where I think we can transform what we call digital transformation.
Thank you. Yeah, very, very, very good observation. I love the kind of the real sort of high level, like really thinking about the problems, right, and the benefits of what we're all trying to do. I think this is the right type of discourse that we want to be having, right? I'm going to pivot a little bit to something that has become an objection to this lab of the future and to this integration initiatives, and that's security, cybersecurity, hacking, and so forth. And we've all heard sort of the fear, the anxiety, the risk, aversion to that. And I want to give the panel an opportunity to talk about where you see the real challenges, but most importantly, let's make it positive. Think about what should we be doing to overcome that. What can we do as an industry to not just get blocked by the fear and actually do something pragmatic that will address some of the risk factors that you see in your own organizations?
So I think before connecting the lab, acquiring the data, we need to think for a basically standardization of module. So we have to go through the security architecture, which talk about, you see, L1, L2, L3, and the demilitarized zone. And then it finally landed into your IT zone. So there is a strong requirement of following the standard of basically of IT OT conversions protocol. So there should be a right set of firewalls, right set of rules, and right set of monitoring like SIMs, antivirus, and event response. We should have a business continuity and disaster recovery plan into the place. If somebody is trying to hack your system, first, are you capable to mitigate this risk? Are you able to identify those risks? How means how your systems are patched, is your systems are patched enough? So if you talk about into the lab, you will still find the legacy system with having Windows 7, Windows 10, 11, the old systems which are not patched from the ages. So if you connect those systems with the connected world, then it's a real threat for us. And simultaneously, the equipment vendors. So we have talked about the mindsets. One is the changing, we have talked about that the scientists should change their mindset to keep these files and folder and something like that. I think if you see the other side, IT people also need to change their mindset. Also, the equipment player and IT vendor need to change their mindset. Because if you buy some equipment and there is some operating system on that one, so if you talk about basically AMC, those they say that no, I will give the basically maintenance for this equipment, but not for operating system. So I think there should be when actually most of the time the equipment being actually purchased through the scientific community, and they also sometime due to ignorance they don't know what is the impact around it. So one is that continuous upgrading of those system with the latest patches is that is the one of the thing. And also you should have a right set of architecture how my data is flowing, whether it is flowing one directional or two directional. So depending upon that you should have a right set of measures and response. If there is an attack, then you should have a emergency response team who can really understand this is the attack and then they can mitigate it. If really your system is get impacted and suppose the lab is down, then how you will execute, what is your basically business continuity plan for 2-3 days once you bounce back.
I think on security, since we have already talked about, again, I would say there are various methods, right? There are 10, 20 ways to do it. You can encrypt your data. You can use logical separation of the data, contextual containerization of information, encrypt your data at transit, rest, and many more. Rather than, I would say, the hackers are using and adopting technology faster than us. We need to reverse this. That is the first thumb rule of saving ourselves, because they are using AI and ML much faster than the business consumer is using it, right? So if we use technology in the same ratio, I don't think so we would have much problem, because there are enough solution available as far as data masking and encryption and securing is concerned.
2 years ago, people used to ask us, can we connect to everything? They have stopped asking us now after we were able to prove that. Last year, people started asking us, can you automate everything? And we have done that. This year, it's all about security, right? So I didn't know, when Jeff and I started this company that we would actually have to become security experts as well. But we have built that expertise in-house, whether it's data security, whether it's data privacy. These are all recent things that you have to do. It starts out with your own security network being secure, right? And you got to sort of build on top of that. If you are deploying a Lab of the Future program, a digital transformation program, you better make sure you get the right sign-off from your security experts within the company. We end up dealing with them a lot, but like David said earlier, there are technologies available, all technologies, whether it's Signals or DLX or we are providing those security capabilities, and most importantly, making sure that we can coexist within your secure system. That's the most important thing, the most important takeaway from my point of view.
So not surprisingly, I have an opinion on this one too. And it goes back to, the need for integration doesn't create new security problems. The security problems are there already. I actually see it as an opportunity to have ownership, responsibility, and ownership, and separating those out across organizations. So I see a benefit in brevity handling, the security for a lot of your data and your knowledge capture and data processing. We do that already. We've gotten good at it. We've gotten certified. We have large teams dedicated to security. And I would say we probably do a better job than, on average, 100 different or 200 different customers that we're hosting for, right? Because we're centralizing and it's our systems. We get really good at it. We can put more energy, more. So that frees you up, right? You have to do less of that. Likewise with the integration, if you know Cytera and Ajit's team are taking the responsibility for a lot of the data motion and encryption and security, one less thing that you have to worry about in security. Now, what you gain there, you have to use to actually secure your concern. You have to have the ownership of your internal network, of your internal devices, of your processes, right? And that's where you put your energy. So I see it as a win in the end. We're separating the responsibilities. We're offloading some of the concerns that you have today, allowing you to care about things that are closer to your environment that you only can control. And I think in the end, it's a positive. That's why I believe this is the right time for doing this now, because of fundamentally that kind of SaaS delivery model, right? That takes off a lot of the weight. Before, you know, today you're doing that already, but you're doing all three. Right? And you're doing all three, and you have the security in all three, and you have the complexity of all three, you have the maintenance of all three. Whereas, you know, moving to this new world, you really actually take ownership of the really important stuff closer to your science. So we have about 10 minutes or so still. So I'm going to open it up to questions. But first, just in case, if any of the panelists wants to, you know, ask yourself a question that hasn't been asked or make a comment that hasn't been made before we take the questions. If not, we'll proceed to the audience questions. Anything else that any of you left in the, dying to talk about?
I think this is the first event which I am attending where with the solution provider and aggregator is I'm seeing second hand, right? And that's very extremely important, because I'm sure when I keep talking people, they say that 20 to 23% people say, yeah, we have 40% instrument integrated, rest are integrated, right? And then 50% say, yeah, we have 60% and all. I think 15 to 12 to 15% people have 100% data of what is being generated is flowing in the system, either downstream or upstream applications. With having this collaboration, I think this, what I understood from the back end, right? This can be an excellent boon to the people who are doing a complete digital transformation, because if you do it things in the digital transactional data, I mean converting entire transaction data to your internal data lake or wherever you are doing, half of the thing you are still doing manually. So you cannot having this partial stuff create more job rather than less job. So when you do digitalization partially, in fact, it becomes double job for you, because you have to gain that stuff in some other format and then make this hybrid system. So I think congratulations and good to see further new updates on this.
Okay, so we'll open it up for questions.
Yeah, so we have collected few questions on the live Q&A. We have two questions. One is from Dr. Natarajan. The question is for the panelists is, how close are we to convert an existing lab into an autonomous lab with available connectivity software we're discussing here? So I think some parts have been already answered, if you can take it.
Anybody wants to take a first crack?
So we have not arrived at present. Actually, we are living in past and talking about future. There is a huge gap in the speed at which development is happening in this area and adaptability of the system. So that creates a gap, and that is actually because of that many people, I mean many companies are still not with the pace, not with the speed, or not at the same present. So for lab of the future, I mean, since this voice command is very common nowadays, so what I can foresee now in future is, as a chemist, I'm a chemist, so a chemist can carry a microphone while doing an experiment and keep talking. Okay, I have taken a sample, 1 ml, it's a red color, and I'm submitting to, it's taken from so-and-so experiment, I'm submitting for HPLC. It will be recorded and entered directly, simultaneously in your EL. So that's the future. I mean, I don't know how long it will take for us to reach there.
Yeah. So I think that the idea of autonomous and magical, and it's exactly we're in the past and we're thinking about the future. So it's probably not the right thing to focus on, but focus on how some of the technologies that are coming in line right now help in the more mundane things that have to happen, right? How the AI can help with co-piloting things, offloading the user from responsibilities. That's more autonomy. Is it autonomous that I say, instrument run my experiment? No, but it's at least minimizing the need for laborious work. Configuration management, right? Now we have low code, no code environments. In some sense, it transfers the load to configuration. You have very large configuration sets, lots of mappings of what goes from where to where, right? There's plenty of technology now that can help with that. The machines are really good at following the patterns and reconfiguring the systems and scaling out the same configuration across larger and larger lab sets. So I don't want to be negative and say that the vision of AI and full autonomy is a waste of time. I think there's very practical things we can do incrementally, but I think we're significantly far away from staying home and letting the lab
Just a quick comment. One, we hear this from our customers. This whole vision of starting with a connected lab, then taking it to an adaptive lab, and then a predictive lab. Right? I think currently we are at the level of trying to build connected labs.
Thank you so much, everyone. We just take this last question, came in the live Q&A, and it's very interesting. So I just probably you all can put your thoughts here. What are the potential risks in utilizing AI for the lab of the future and the mitigation measures?
Yeah. So I think let me attempt that. So any innovation or any creativity come with by default risk, provided that how we calibrate that, how much to be taken. I think there was a joke, somebody did a data analytics in the I don't recall, in the US CSOR, and then they predicted that during summer people die by eating ice cream, and they think when they go for swimming, because the sale of ice cream is in summer very high, and the more people come, and hence the incident is high. So AI predicted, because of ice cream you die. So it's not like that. What I say that again, technology can give you excellent predictions. The judgment has always been a human augmented judgment, and in fact the clear action has to be decided by us. But yes, what I see with if you do not have clean data foundation, I'll not talk about data foundation, because people have system of record by more or large in various places. But what is needed, a clean data foundation, and if clean data foundation is there, you can reduce the hallucination what technology gives you, and that is where you can mitigate the risk. There are various other ways to mitigate the risk, but yes.
Sure. Thank you so much. Any other comments?
I would say that to me, the biggest risk is a misuse of the technology, a misunderstanding of the technology, right? We're going to get into trouble every time that we assume it can do more than it can do, right? So the mitigation is outcome. Focus on what value you're getting out of the technology. Verify that you're actually getting the benefit that you're trying to get, right? Rather than focusing on the excitement of it working alone, or it being more powerful than it is. Use it as a tool. Always use it as a tool. Validate whether the tool is good. If you use a shovel, you make sure you make a good hole, right? So if you use AI, make sure that you end up with the right hole, right? So just focus on that as the mitigation strategy, because the risk is early technology is going to fail us, until we figure out how to get it right.
Yeah, identifying the guardrails around the data that you are presenting to your AI tools, right? And making sure that the AI tool you use is limited to your data only. And fortunately, there are many AI LLM models that are available that allow you to provide that limits. You don't, the minute you start exposing the LLM model to public data is when the issue comes up. But if you limit it to your private data, there's some wonderful things you can do with it.
Thank you so much.